Wheels is self-announcing, right? Yes. They have a whole bunch of ambassadors that spread the good news of their seminars today. Always a big draw. They're like the rock band of science seminars, aren't they? Whenever Wheels comes out, man, yeah, give them a warm welcome. So Wheels is going to be presenting today. Afterwards, we'll have lunch in the Joyce Room if you want to join us and ask more questions about them. Otherwise, let's not take any more of their time, and we'll let them go. Go ahead.
Awesome. Okay. Yes. Well, thank you all so much for being here. We are, as Dr. DeBoer said, the Wheels team. I'd like to start by having everyone introduce themselves, and then we'll get right into what the Wheels project is. So my name is Bridie Davis, and I am a junior exercise science major here at LeTourneau.
I'm Joseph Bowen. I'm a biomedical engineer.
I'm Carissa Zwerg. I'm a freshman biomedical engineer.
I'm Professor Edward Hamilton, and I teach in the physics department.
I'm Allison Hilbig. I'm a computer science and engineering major.
I'm engineering myself.
I'm Heather Bain. I'm a psychology major.
I'm Natalie Donald. I'm a biomedical engineering major.
And I'm Karen Richmond.
Richmond faculty, and then we have Dr. Schaefer here too. And she is a psychology professor, so we have our faculty members. So I guess, as you can see, it's a very diverse group of students here, a lot of different majors. One of the first things that we sometimes have to clarify with Wheels is that it's not a senior design project. There is a wheelchair senior design project, but we are an interdisciplinary project. And anyone who has a heart for people with disabilities or a heart for research or assistive technology can get involved. So how many of you have heard of Wheels before? Okay, awesome. So a lot of you guys are like thoroughly familiar. Well, we're going to kind of get into the details of what it is that we actually do. So the Wheels project essentially exists to try to improve the lives of wheelchair users, wheelchair-bound people in low and middle income countries. So we do a lot of work in Kenya. Countries like that, being a disabled person has a lot of not only physical barriers that we might not face here, but also social and societal problems as well. And so we try to work to improve their lives by helping them get not only wheelchairs so that they can have mobility, but also wheelchairs that work for them. And so the way that we accomplish this is through field studies here on campus and in Kenya, so you'll hear about that first. We also develop and use questionnaires to assess wheelchairs. And then one really important part of Wheels is getting our research out there. So we try to publicize it, and we present at conferences, and so you get to have a taste of that at the end of the presentation as well. So with that, I'll let Joseph talk about the wheelchairs.
So I'm really excited to be on the Wheels team. I hope you guys are just excited to hear a little bit about what we do. So since this is the Wheels project, the wheelchairs are very important. If you've been around the engineering labs here in Glassy, you've probably seen us wheeling around these bright yellow wheelchairs. These are the Hope Haven Bumblebee chairs. We really like them because they're affordable and they're adjustable. The parts just slide together and then are bolted together. Each hole is 1 inch apart, which allows us to have quite a range for adjusting parts. We can adjust how far apart the back wheels are, how high or low they are. We can move the seat around. And most importantly, we can adjust the length of the wheelbase, which is the distance from the rear axle to the front caster. That's really important because the research we're doing is focusing on how the different lengths of the wheelbase affects the pushing of the wheelchair. It's also really durable, which is really important when handing wheelchairs over to engineering students to run tests on. The other wheelchair we're using is the Free Wheelchair Mission Gen 3. These wheelchairs are provided for those in Kenya, which is really cool. They're also foldable, which is really helpful for storage and transportation of the wheelchairs. They're also really durable, which is important for low-income areas, since paved roads and sidewalks aren't as available. Next, Carissa is talking about testing.
For this semester, we're working with Dr. Hamilton to study the length, how the wheelbase affects rolling resistance. So we have 3 of these Bumblebee chairs, each with a different wheelbase, 17 inches, 15 inches, and 13 inches. And in our test, we will roll each wheelchair around a rough terrain track for 4 minutes, and a participant a participant will push it around and will count the number of laps they go in order to calculate the distance that they traveled using the aspects of wheelchair mobility protocols, which help us to regulate how we set up the track and what we do. This test will help us prove that the wheelbase does have an effect on rolling resistance, which we can tell the manufacturers to improve the wheelchairs for people around the world who get them. In Kenya, we're using the Free Mission Wheelchair Gen 3 to study the impact of the center of gravity on rolling resistance by changing, each of the wheelchairs in Kenya have the back wheels in a different location. Some's one further up, in the middle, and in the back. This affects the center of gravity, which we can then test using the same aspects of wheelchair mobility protocols to figure out that the center of gravity does have an impact, which we can tell the manufacturers to improve them. Dr. Hamilton will talk about more technical stuff.
Okay. Let's go ahead and first think about what kind of a physical system we're dealing with right here. One of the big appeals of this as a research project for students is that you really can tackle a full understanding of the theory of this type of a system using only first semester introductory non-calculus physics. What we're dealing with right here is a system where you've got a few points of contact with the ground, and you have two very different types of wheel. You can see we have a big wheel in the back and a small wheel in the front. A couple of summers ago, I took data that confirmed more or less what I knew was going to be true, which is that the back wheels, the ones that have the big radius, have a much better effective coefficient of friction with the ground. The rolling coefficient for that friction right there is much lower for the back wheels than it is for the front wheels. And what that means is when you're in environments where friction begins to become important, if your ground conditions are less than optimal and friction suddenly becomes a major concern to you, all of a sudden you care whether your weight is being distributed more towards the back wheel or more toward the front wheel. The more weight you put on the front wheel, the harder it's going to become to push things. And so if you're the sort of person who works in an environment where you frequently have to deal with surfaces that are far less than optimal, then you really start caring a lot more than you did before about the relative distribution of weight from the front to the back. So we took a bunch of data using several different types of wheels, all the different wheels that we had that we could take off of chairs that we had at the time. We put them onto a rig that we built that was a specialized rig, and we ran them over this artificially bumpy surface, this simulator that we had inside that was made of wooden slats that were laid end to end. And then we took data that could be used to extract the effective coefficient of friction associated with both types of wheels, because we could use those as inputs to a theoretical model that I built on Mathematica. And the theoretical model just involved very basic introductory concepts that are related to factors like the torque being created by contact with the ground at different locations, where you apply force to the system at the top over here. And what we want to do now is go back and confirm that that model, at least on some qualitative level, is consistent with the experiences that people have as they attempt to push a wheelchair over surfaces that are at least somewhat rough. And so we're trying to take, there are a bunch of different things you can change about this. We try to minimize the number of different things that we change at the same time, the number of what scientists call degrees of freedom, down to just a few things. So we can control the center of mass, and we can control the separation between the rear wheel and the front wheel. And both of those things have the effect of allowing us to control how much of the weight rests over top of the back wheel and how much of that weight rests over top of the front wheel. Ideally, what we'd like to discover to confirm the theoretical model that I already have is that people will feel a lot more comfortable when they're moving over the rougher surface when we have a longer wheelbase. So my initial hypothesis is that as you go to rougher and rougher surfaces, and especially if you have to push in a way that's constrained, you can't push down in the wheelchair to lift it up to go over the surfaces and take weight off the front wheel artificially, people are going to be a lot happier with a longer wheelbase that ensures that the majority of the weight is distributed toward the rear of the wheelchair. This right here is a diagram, and you can see all the different aspects of physical parameters that go into this model right here. What you're looking at right here is the difference on the left between a self-propelled wheelchair and a wheelchair that's being pushed by an assistant pusher. And you can see that there's a meaningful difference in terms of the way that forces are being applied to those systems. And when you look at that, you instantly realize the big story, the major problem that you have if you're in an environment or in a situation where you need to have an assistant pusher, the way you apply those forces is completely different. And in particular, as you apply the force in the picture on the right-hand side over there, what you effectively do is when you encounter a rough surface, you need to push harder. When you push harder, you're effectively applying a torque about the point of contact in the back of the wheelchair that grinds the front of the wheelchair into the ground. So the harder you have to push, the bigger the problem of the poor coefficient of friction from the front wheels will start to become. And that's a thing that we want to take more seriously. We feel like when chairs are designed for environments in which the majority of people don't use assistant pushers, when they're self-propelled, that type of consideration is not in the forefront of the minds of designers of wheelchairs, and we'd like to produce a story that we can tell to people that emphasizes that the world is very different when you rely heavily on assistant pushers, and when those assistant pushers have to function in suboptimal environments where surfaces result in considerably more frictional contact with the ground. Okay, I'll turn this over to Allison.
Thank you. So in order to collect this data, we use questionnaires that have been developed by the Wheels team, both past and present. These questionnaires are reviewed by people in the scientific community, and then we publish them for public use for similar studies. So they're available on latu.edu/wheels. Currently there are 2 different PDF forms of 2 questionnaires that we have up there, but by the end of the semester we're going to have 5 different questionnaires available. And we're also going to have downloadable data files that correspond to those that work in conjunction with an application that was developed by one of our students last year, Jason Saylor. So the Wheels Data Assistant is this application, and it will be available for download by the end of the semester. Essentially, it's a central electronic hub that you can import questionnaires to that you've downloaded, and you can also create questionnaires within. The nice thing about it is you can collect the data within it, and it will store it into an Excel file. So once you have those Excel files stored, you can also just with the click of a button summarize all of the data for any given questionnaire corresponding to a specific questionnaire, and it'll just spin up a document that gives you all the data, the averages, and everything you would need. So this is what a PDF version of a questionnaire would look like. As you can see, it's got demographic data and then a sliding scale so that you can rate the different experiences that you may have. And then this is a Wheels Data Assistant version of the same document. So as you can see, it has the sliding scale translates very well to the application, and instead of having to, what we do with the PDF is we get a ruler and we measure how far along that line is. With this, it automatically translates it into a numerical value for us. And as stated earlier, you don't have to lug around a bunch of paper when you're using this. You just have your application on your phone or on your device. So with that, I will hand it over to you.
So one of these questionnaires that we've used the past couple of years is called the Wheelchair Questionnaire for Condition, the WCQC. And the whole goal of this questionnaire is of safety for the user. What it does is it looks at a wheelchair and it says, okay, looking at specific parts on the wheelchair, and we're going to evaluate their condition. So instead of looking at the wheelchair as a whole and saying, is this a good wheelchair or is it broken, we're looking at the armrest, the caster, the foot plate, and saying, okay, how does this bring for condition? And so the whole point is safety, because if you have a backrest that isn't giving enough support, you're going to have spinal problems. Or if you have a cushion that's worn out or old, it's going to give you sores. Or if you have brakes that aren't locking, you can go flying down a hill and it's going to cause a lot of problems for you. So the way it works is you have the questionnaire, and we're going to have physical therapists fill out the questionnaire when looking at the wheelchair. We use PTs because they've been around wheelchairs and they know what is broken and what needs some fix. So we have several PTs look at a single wheelchair, all filling out the same questionnaire, and that'll give us an accurate picture of what's wrong with the wheelchair. And then we have several wheelchair you have them fill out over several wheelchairs, and you get a good picture of what's wearing out the quickest in a certain environment. And you'll get a table kind of like this, where you have a component and then its rating in this environment with this wheelchair. And the questionnaire gives you a good picture of this component is failing most quickly here, which sometimes is obvious. So if you're in a hilly environment, you're going to expect the brakes are going to wear out a lot quicker than in in a flat place. So the WCQC can bring up that, but it also brings out things that aren't so obvious. So a couple of years ago, and it showed this one, I think, it showed that the foot plates were wearing out really quickly, and we didn't know why. And it turned out one of the reasons was because when the children, they're sitting on the chair, and then they want to get out, they end up like kind of wiggling and hopping down on the foot plates and then the floor. And the foot plates were kind of their stepping stool to get down. And that was something unexpected that you can't expect it, but foot plates were wearing out and then having problems with the wheelchairs because of it. So that's something that WCQC can bring up. And the usefulness of this is when manufacturers are making a chair, and especially when you want it to be cheap for donors to be able to give, you have a cost and quality tension. Could you ramp up the chair so it's never going to fail, or like send as many spare parts as you can, or yeah, how do you make that decision? And the WCQC helps tell you which parts you need to send spares and what kind of decisions you make with that. So this will help make those kinds of decisions, and the whole goal is safety.
So I'm going to talk about the wheelchair interface questionnaire, and this is a really new questionnaire. It's been in the works kind of for a while now, but essentially has been developed over the past year, and not so long that I have been working with this. So I'd like to tell you what it is, first of all, and kind of explain it, and then talk a little bit about that development process that I've been through. So the wheelchair interface questionnaire is a questionnaire that is designed to look at how a particular wheelchair works for a particular user. So essentially it's trying to find out about the appropriateness of a wheelchair. We've assessed condition, as Ethan was talking about, and there are a lot of measures that will assess mobility or the quality of life of a wheelchair user. But the problem with those kind of tools is that quality of life can be really skewed by the differing conditions and capacities of wheelchair users, as well as what they're able to do in their wheelchair. So with our questionnaire, the goal is to take into account those differing capacities and essentially compare what the wheelchair user is able to do with their chair to the maximum that they could be able to do. And that kind of removes those variables and helps us have a more accurate picture of how that wheelchair is interfacing with that user. So this questionnaire produces continuous data as well as qualitative data, and you've already seen a picture of what the sliding scale looks like, but I'll talk a little bit more about that in a minute. I just want to mention again some of the benefits and the reasons why we felt there was a need for this questionnaire, not only to get that information about the interface, but also to have something that would be useful in the field. It's brief, it's only 9 questions, with one question having 4 subparts, so it can take 15 to 30 minutes to complete by a wheelchair professional. It is widely applicable. We've designed it so that it will be inclusive of pretty much all manual wheelchairs, and then also as many conditions as possible as well. So you're not going to be limited by what a user is able to do. It also does not require an interview, so you can assess the wheelchairs of users that are nonverbal or users that speak a different language, which really therapists encounter a lot, especially in low and middle income countries. Here's an example of a question on the questionnaire. As you can see, we have that rating on a scale, and essentially you can mark anywhere along that line, which is what produces that continuous data. And I don't know all of the statistical details, but essentially this means that we can use a program called ANOVA, which is parametric analysis, and so that can tell us a lot about what is happening, give us really detailed information about this specific factor of the wheelchair. But at the same time, we have a comment line, and that tells us the qualitative information. Okay, what's really going on? Why did you give the chair that rating? And that's going to help the manufacturers change something. and it will also help therapists make decisions when they're fitting someone for a wheelchair. So it's going to be able to be used by wheelchair manufacturers, therapists, clinicians. That's the goal. And so the development process started with working with a bunch of wheelchair experts. We want this questionnaire to be used by clinicians and therapists. And so our goal was to do a Delphi-style survey, which essentially means getting a round of experts and sending out a survey about a particular phenomenon, in our case, the questionnaire. And then once you get feedback and you incorporate that feedback, you send it again and again until you get close to consensus. That's kind of the idea. So we did 2 rounds of this Delphi-style survey, and then we did a focus group in Kenya. So this was with wheelchair professionals that are working right there in that environment that we want the questionnaire to be used in. We got feedback from them and continue to refine the questionnaire. And both of these steps not only helped us to create a good questionnaire, but they also show that the questionnaire is valid. It's got face validity that's affirmed by experts saying, yes, this looks like it measures what we want it to measure. And it also has content validity with that group of experts affirming that it's a good representation of the wheelchair interface that's on the questionnaire. So the next step is publication, and that's what we're in the middle of right now, hopefully in the next couple of weeks. So I've been working on a paper that demonstrates that development and validity study process. And so we hope to submit that, and that will make this questionnaire available for anyone to use to assess wheelchairs. And then in Kenya, we plan to continue our validity testing as well as to do testing for reliability. That's really the next step to make this questionnaire as solid as it can possibly be. Just to kind of quickly show you an image of what all of these studies kind of look like and what they mean in real life. This table shows the scores that our experts gave for each round of the study and then for the focus group. So it's not super interesting, but they rated it from a scale from 1 to 7. So the fact that all the scores are above 5 is actually really good. These are the questions that ended up on the final version of the questionnaire. We deleted or edited questions that were rated under 4. And then you'll notice that the focus group has essentially the highest numbers throughout, and so that's really good because it means that we kind of improved as we went. And so that's just an example of what the data looks like from this study and what has led to the process of developing the wheelchair interface questionnaire. And with that, I will give it to Heather to talk about another questionnaire. Good morning.
Bridie explained pretty well the Delphi process, which is also what my 2 measures that I'm working on are going through, have been going through. So the 2 documents that I've been working on are the wheelchair satisfaction questionnaire and feedback on wheelchair satisfaction questionnaire, which have been in development for a long time. I've come along and we're doing more editing, tweaking, really tightening it to make sure it's the best that it can be, and that the Delphi situation helps with that. The wheelchair satisfaction questionnaire is 16 questions, which is administered to people 18 or over who have been in a wheelchair for at least 6 months. Then they are given this questionnaire, and then they are given the feedback questionnaire, which is simply their feedback on what they thought of the questionnaire. So that invites them to rate each question, and then there's a final question of, what do you think of the questionnaire in general? And the first question is, how do you feel about a questionnaire? So there's a point to all of that because Bridie talked about content validity and face validity. With face validity, we want to make sure that we're measuring what we want to measure. That's the simplest way to put it. Is the data we're collecting going to be valuable? Does it matter? Is it relevant? And content validity is the degree to which whatever this measure is representative of what we want it to represent. This is why it's important to give these questionnaires to people who are in wheelchairs. I don't know what it's like to live in a wheelchair every day. I can't really, with any sort of integrity, rate a wheelchair. So there's a phrase that's very important in the disability community that we've heard several times. Nothing about us without us. So we want the information to come from the target population. You know, anytime you do a study, you pull a sample, and you want the results from that sample in your data to generalize to the population, the target population. We're trying to help people who are in wheelchairs, so we are going to people in wheelchairs who can give us good data. So, oh, I didn't mean to hit that, I'm so sorry. So, in short, if I were trying to design a measure of mathematical acumen and suitability for college, and I were going to give this questionnaire, this measure, to matriculating college freshmen, I would not probably go to a panel of French literature professors to design, to say what is the content, to get content and face validity, I'd go to mathematics professors. So it's very specific who we're asking for information and feedback. And then of course it goes to experts, it goes to peer review, all of that happens, but the initial data is worthless if we ask people who aren't living in wheelchairs every day. So we're redesigning these final satisfaction questionnaires and the feedback questionnaire and then field study here. So they will be administered, they're sort of in the final stretch of editing. Hopefully in the next week we've got our final answer. And then we administer it here to a sample of people here who are in wheelchairs. And we make any changes based on the feedback questionnaire, which for all we know, we may have many changes. We may have very few. It just remains to be seen. And then we take our final product to Kenya, we collect data, and that data eventually is reported and goes to wheelchair providers and manufacturers because they need this information as everybody else has sort of laid that groundwork. If they don't have the information, they can't make design changes. If they don't have the information, they don't know what to change or why. So it needs to be relevant. So in closing, for me, the reason that face and content validity are so important and that these questionnaires and assessments and tests and measures be correct and scientifically valid is because everyone has a part in this project. Everyone has a different, I'm not doing any of the physics. You should be glad that I'm not doing that. So we have people that are doing design, physics, biomedical, all of that, engineering. I'm doing my part because the whole point, the larger point of the project is not, let's do some research and learn about how to do research. That's important, and we're learning a lot. This is the point of what we're doing. So every component has to be right, it has to be tight, it has to be correct, and it has to be valid. Because this is the goal, is to change the reality of people who are living in the year of our Lord 2017 with wheelchairs that do not work, or they're broken, or they're worthless for the environment they live in. This is what pulled me into the project. I did not know this reality, and then once I knew it, I could not unknow it. We've all been through something like that. So this is what everybody's piece of the pie, so to speak, is going to this hole. We want to make things better, and it's a problem that can be solved. It really can. So that's the goal. And I will try to.
My name is Natalie Dowell again, and I was part of the Wheels project last year, and my part was working on the aspects of wheelchair mobility test. So we did this in 2 phases to assess, this is a within subjects test, and so what we do is compare wheelchairs to other wheelchairs instead of comparing the performance of each participant. So phase 1 was done here at Laterno with students pushing wheelchairs, and then phase 2 was done in Kenya with people propelling themselves. And so the data that we collected there, using distance measurement and again like the questionnaires that we have, the aspects of wheelchair mobility, we get that data and we give it to manufacturers, and they're able to redesign or improve the design of their wheelchairs. So I actually made a poster with the data that we collected and assessed, and then I'll be presenting that at a conference. But I'm also presenting it today right after this presentation is over. So we invite all of you to come over and look at that and ask questions and discover more about that. So now we'd just like to say thank you for listening to us, and if you have any questions, please ask us.
We've got plenty of time for questions. We would like to end a little early so that you guys have a chance to see Natalie's poster a little bit before lunchtime, but we still have plenty of time. So any questions that you have, it's kind of a broad overview. Yeah, okay.
question for you specifically, Bri, actually.
Okay.
When describing the surveys, they said that these surveys would be available to everyone, and yet they only seem to pertain to A, people who are in wheelchairs, or B, people who have actual skills assessing a wheelchair's competence. So how do you, and I know this is maybe an odd occurrence, but we live in a fallen world, so how do you consider, like, people with unskilled experience, or just some random person decides to troll you guys with low results? How do you factor that in?
Someone unqualified uses the questionnaire, essentially, is kind of your question. The
Because you
questionnaire.
did say it was available to
Right,
everyone.
Right,
As
well,
in,
and
I
that,
can take the
and that
survey.
is the goal with the wheelchair data assistant, although I do believe they will have to request access, for one thing, yeah, Mrs. Smith.
That's a good question, and it's something that is really an open access question.
Yeah.
Anytime anybody makes something available online, you are at risk of that thing being used incorrectly. But rather than not make it open access, we have, with the permission of the Turno's intellectual property people, agreed to put it out there open access so that the providers and so on overseas can use it. There's probably not a lot of benefit or stick-to-itiveness for someone who doesn't understand the reason for it, to use it and stick to it. So we've decided to do that. When people are actually designing wheelchairs, that becomes more complicated because they can be manufactured overseas without proper quality control. And many of those people have now pulled theirs from open access and have tighter controls. But that is an intellectual property question.
No, that's a great question, and the questionnaire does have a demographic section, not only, for mine, it's therapist rated, and so not only does the user have their demographics, but also the qualifications and years of wheelchair experience of the rater. So the goal is that you can see, okay, this rater knows what you're talking about, or maybe they don't. Whether people are honest as they fill it out, we can't really control, but the hope is that, any studies that they did publish would go through that peer review process and hopefully not make it in if they're not honest.
And just to summarize real quickly, we wanted to give feedback to the manufacturers. We wanted to know how well the wheelchairs roll, which is the two ends of our line here. Aspects of wheelchair mobility. You guys down there and there. And so these, at the ends, are doing that. And then we want to know if they broke quickly, and that's what Ethan was talking about. We want to know what the therapist thought of them, because they have a big frame of reference about what a good wheelchair should be. And we wanted to know what the wheelchair users thought about them. So that's why there are these different questionnaires. They're very different, and if we mix these things together, you get a bland soup that tells you nothing, which is what we found with some of the other questionnaires out there and other tools. And it was really neat what Heather had to say here, that we really want to make a difference globally, and you all may have heard that I'm going to be leaving Laterno, and actually to address some issues that came up from Wheels that we can do something about. And so next week's science seminar, we'll be looking at some of the global picture with what's going on with wheelchairs and so on.
I had a question. You said it was available to people even if they had other languages, but obviously the questions are still going to have to be interpreted. So what does that mean it's available to people in other languages? Because it would still have to be interpreted.
Yeah, I think specifically in the presentation, I mentioned that you can use the questionnaire even when users have a different language. So the idea is that you don't have to interview a wheelchair user for the wheelchair interface questionnaire. However, they are all in English, but part of the development process was seeing, is our language standard English that can be easily translated and understood for people speaking English as a second language. Because of all the languages, English is a very global language for scientific studies, for internet communication. So that's the big goal, but that was something that we considered throughout. And we had a few wording changes and things like that because we wanted to make it accessible.
Off in a different direction. You studied how far apart the wheels are and the wheelbase. Did you ever study much about how big of that little caster wheel is, how fat it is? I mean, like I see airplanes that fly in Alaska, for instance, they have wheels that are this wide and like this, as opposed to something what we see out here.
When we were doing the control experiments, we were going to move the wheels and put them onto this rig that we would drag at a fixed velocity over this artificially rough surface. we were able to swap in and out wheels that did have some variation of those parameters. So we were able to see some modification of the rolling resistance with respect to things like the diameter of the wheel and the thickness of the wheel and things like that. For the most part, I think that the difference between the big rear wheel and the small front wheel is a lot more important than those other differences. You'll see small differences. This difference right here is a factor of 2 or a factor of 3, whereas the difference between having slightly fatter or thinner wheels ends up being more like a difference of 20% or something like that. So it isn't drastic.
I'm assuming like ideal terrain standards for a wheelchair would be something like the hallway up there. But can you give me an example for the users in Kenya? What's a worst case scenario that they frequently encounter? Like, are we talking mud? What kind of an incline? Rocks? Like, what did you see worst case scenario for users in Kenya?
Yeah, there was a lot of, for example, there was dirt roads or roads that had lots of rocks in them, and we found lots of dirt roads, especially in Oklahoma. And yeah, a lot of people don't have like nice hallways, and like the school we were at, each like building has limited amount of hallways, or they were like concrete that wasn't that nice. And there's also like curbs around that you have to get up and over. There's slopes at the school that we were at. But mostly was like the hardest part would be the dirt roads or the dirt with like rocks in it that they had to kind of push over and roll over.
And also, this the school we were at, it's the school for people just in wheelchairs, and the funny thing is it's on a really steep hill. It's weird. So for people in classes and stuff, it's like this steep, and they're going down and like lock the brakes to like skid in the brakes wear out really quickly, and they're really strong to like get back up the hill, and it's tough.
Going off of that, you said that it was at a steep incline. If steps were ever added to that, would y'all ever think about designing something to maybe go up steps, or would it just focus on
The actual Wheels project, this one, is not a wheelchair design project. We're responding to wheelchair manufacturers with existing stuff. There is Frontier Wheelchairs that does some design, and there are people who have built the equivalent of wheelchairs that go up and down steps, but you have that tension that Ethan was mentioning between the cost of something and how, and what you could build with something someone could actually do. Even here, nobody buys their own wheelchairs. Insurance pays for it, and it's limited. Like those wonderful exoskeletons that anybody can walk in, most people would never be able to get.
What kind of research are wheelchair manufacturers currently doing that are affecting the way that they're manufacturing the wheelchairs?
That's a great question. Sounds like a really big picture question. So I don't know if you know what's kind of current for wheelchair manufacturers.
Like I mentioned, that tension between cost and so on.
Yeah.
We're interested in low and middle income countries. So a lot of the engineering that's being done for those countries, in the last 10 years, there's about 15 companies I know of that have tried to address this issue. And it's the tension between what can we afford to do and what can be done. And also the mention of rough surfaces. How do we change this? Because even if you use a $20,000 or $90,000 wheelchair from North America, you put it on those rough surfaces, it doesn't last long, you can't get parts, so it's not really a good solution. So they're mostly struggling, the question that the team this semester and next are going to be answering regarding the center of gravity and wheelbase is of great interest, because these people want to know what sort of wheelbase should be set up. And then you have the tension, well, you got to take it inside, what do you do if it has this really long arm? So, as usual with engineering, they're doing the tension between the two. There's one guy who's trying to work on a power chair option, because in North America, anybody who can't self-propel well usually has a power chair for mobility. That hasn't been the case overseas. That's a very difficult engineering question.
In regards to going up hills, I would think maybe you could put a brake that anti-locks against going backwards, kind of like kids' bikes, have something like that. Have you looked into anything that could maybe help, that would be cheap and affordable for going up hills?
The simple ratchet system seems like it could possibly work.
They've tried that, and there's one out there called, what's that one from MIT with the cranks on the loop? Nobody uses it. They've actually distributed it, and people are just like not touching it. And they can make one with the cam, they've tried that with the cam and the brake. Most people who are fit wheelchair users use what's called a wheelie to deal with things like that. And if you start messing with them with brakes that make up it, that lock their wheels without their permission and so on, they're not happy with you. Because they've learned to sort of ride the thing almost like a unicycle. Now, we people have someone pushing them and who can hang on, if they're big enough. If you look at the Wheels website, you often end up with little kids helping little kids. So those are great ideas. People have actually done it. There's a leverage action chair, if you want to look it up, that MIT designed. And they even tried to distribute it, but everybody hates it. So the wheelchair users, when you're back to this, they would not think good things about that leverage action chair. And now I haven't had it in the study for this yet.
Yeah, we can think we know what makes sense. We're not, if I'm not in a wheelchair every day, my opinion is, I don't want to say worthless, but of very little value.
So all these wonderful MIT engineers come up with a great idea, and they give it to wheelchair users, and they're like, really?
What's preventing from having the capacity of having an adjustable wheelbase where by adding another lever, say off to the side, where they can, where for different, say if you need to be outside and you plan on going for a long distance, simply shifting the lever and it pushes the wheelbase out farther. And then when you're going interior, closing it and bring the wheelbase closer so that you can go around corners and things.
The thing about moving parts is that's just inviting failure, and so the less adjustable parts we have, the less breakdowns in the wheelchair that would happen. I mean, as nice as these things are, it's actually really hard to pull the wheelbase in and out. We had to get a rubber mallet for one of them. You know, they're built very good to do what they do, but adjusting stuff is just not always easy.
And actually, somebody did make one like that, and it was pretty much the same response to it. The coolest thing I've seen is a little thing you clip on the front that gives you a single bigger caster and a long wheelbase all in one thing. I've seen that used. We should.
Yeah, I think we're right around, maybe one more question, then we should give that time, so, yes, Cameron.
I noticed that most of the wheels analysis was mostly about the length and the girth and all that data. Is there any research being done on the actual materials of the wheels? Because I feel that that would have a big effect on the cost effectiveness and the durability and even the reducing the friction. So the project is called Wheels, so is there any analysis being done on the actual wheel?
The wheels, material, I mean, that would be a little bit,
Yeah, I think we might address that a little bit. We find out what actually fails. So, for example, this particular wheel, after about a year and a half, this thing comes off in chunks if they didn't have it done. And so we find that data out with the Wheelchair Components Questionnaire for Condition, and then we feed it back. Now, as far as just plain materials testing, that's ISO standard stuff, not my bailiwick. That's Frontier Wheelchairs and that kind of stuff.
So you guys aren't really doing anything on the actual wheels?
We provide feedback to manufacturers kind of twofold, the condition and also aspects of wheelchair mobility, and that tells them how their wheelchairs are doing as far as how they're holding up and how they're moving for people. And so then it's on manufacturers and on clinicians to respond to our tests and decide we'll try something else or we might do something different. So once again, this is all kind of tied up in Wheels being a project based on what the technology that we have and seeing how it works versus, another project like the Sphere Design project, which is can we find something that works better and put it in, on our own and design it. So yeah, that information is there. It does come from these questionnaires. It's just not as specific, I think, as what you're asking about the material.
I want to emphasize, we did collect data with a variety of different configurations and types of wheels. In particular, the front caster wheels come in various shapes and sizes. So you'll see some that are more like this, you'll see some that are inflated, some that are solid core, some that are just basically cylinders of solid plastic. We had ones that were much wider than this. And we tried all those different possibilities, and what you discover is that even though they look quite different, they usually end up having pretty similar energy cost characteristics overall. The energy cost characteristics are governed heavily by front versus back wheels as opposed to the precise shape of each particular wheel.
And so would that change at all if the wheels were different material?
I think material is going to influence things like durability more. I don't think it's going to have a substantial influence on energy cost analysis.
We should probably give Natalie time to say where you're going to be.
Yeah, I'll be right outside around the corner to the right, and you guys can come and ask me questions, whatever. Thank you.
All right. Thank you.